Hello and welcome to Risc-V emulation in a high-level language. And welcome back if you are a previous viewer. We are going to resume the work that was done last time where we started an actual assembler which takes text, like a text file containing assembly language statements or instructions and converts it into something that we can execute on our Risc-V processor. Last time we went through and wrote the lion's share of the assembler that analyzes the contents of the file and chops it up into tokens. These tokens are the things that we'll be dealing with in this episode. But there was one thing that we didn't finish last time, and that was how to deal with new lines in our file and what to do with comments. Now, assembly language is a very line-oriented syntax. If we go back and take a look at our assembly language program, every single line is complete in of itself. Unlike, for instance, the C# programming language or Python, the structure of an assembly language program is not block-oriented but line-oriented. So it makes sense, therefore, to generate the end of line uh, as a symbol or a token in of itself. So that way, when we're running our assembler, we can recognize sequences like a word followed by 3 numbers. That is probably an instruction if it ends with a end of line. So we want to recognize the end of line, and we also want to recognize comments and ignore them because they don't really they're not emitted into the assembly language program. They're not executable. So we're going to add support for this in our assembler. And we're going to go back to our unit test, and let's start by looking at what does it mean to recognize a new line? Well, here we run into an age-old difficulty for anybody who's parsing text. Depending on which operating system you're using, the definition of what a new line is will vary. And on Unix, and for a very long time, since 1970, a new line is a single character new line, which is ASCII code 10 and is denoted with the symbol \n. So if I encounter one of those, I want to get the token new line. So let's write our test case. So here is some spaces followed by a new line. Now I want that to be a token end line. Let's call it end line to signify that we've reached the end of a line. I'll copy the code from the previous case, and what we'll do is we'll assert that this is end line. So the first token will skip over the spaces, hit the new line, and that should result in an end line. And after that, I expect an end of file. So if I read a second token, we should see this. Okay, so let's write the code that does this. We'll go to our text assembler, and what should happen is in our base state, recall that we are maintaining a base state here. If we see a new line, then we shall handle it as follows. We will increment our line number because this moves us to the next line, and then we'll return token.new or end line. All right, so if I run our tests now, I'm expecting that to pass. My machine is very slow today. Glacial, I'd say. Fascinating. Machine is working very hard. And yet we're not loading the CPU very much. Hmm. Well, this is as exciting as watching paint dry. I'm really fascinated by how slow this is taking, or how slow this is. Look at those compilation times. They're horrific. And we still haven't run our tests. My goodness. Yeah, our CPU is not that heavily loaded. Well, here we go. We finally got our test result. 2.5 minutes later. Okay. Well, well, we're satisfied then. We were able to read a new line, and then after the new line came an end of file. I'm going to push my luck here and actually add a space there to confirm to myself that running that unit test will handle the case when there are preceding spaces to the end of line. But this is spectacularly slow. Hmm. All right. All right. Well, in any case, the test completed and it looks good. This is going to put a little crimp on the presentation this time because of the slowness of my machine, but we'll proceed and hopefully this doesn't get any worse. So we just discussed the new line that is used on Unix systems, but on Windows systems and previously on MS-DOS and older environments like CPM and and so on, the new line a new line is represented by two characters. You first have a carriage return and ASCII code, and this goes back to the days when computer displays were printers or teletypes, where you had to tell the teletype first move the head of the output all the way to the left margin. That's what the /R or carriage return ASCII code will do. And then /N new line is actually a line feed. That means scroll the printer's paper up one step. So moving the cursor back to the new line of the next line, to the beginning of the next line, is actually accomplished with two symbols or two control codes. So for Windows, we need to handle this case. And then to add another problem to the mix, on other operating systems, such as, for instance, the classic Mac from the 80s, um, Mac OS Classic, the line separator was not a new line, but it was the carriage return symbol. So we want to handle this case as well, in case somebody's still writing software using an old Mac. So in any of these cases, we want to be able to handle carriage return and line feed, or just carriage return or line feed. We've already dealt with line feed, but now we have to handle this case where a carriage return needs to look at the next character to see if the next character is a new line, because then we want to swallow that new line and make it sort of part of the whole token, carriage return and line feed. If we didn't do this, we would get two new line. First one handled by the handler for the carriage return, and then the second handled by the handler for the new line. And that would give us incorrect results. So we need to handle this in a special way. And so what we do is we go to our assembler and we go and we say that we have seen a carriage return. Good. So we'll shift our state to carriage return state. And then we continue. So the idea here is that we can't make a decision of what about what we've seen until we've seen the next character. So in this case, we saw a carriage return. We've remembered that we've seen a carriage return. Now we need to add a handler for this new state, which is down here. So once I've seen a carriage return, the next character, when we arrive here, will be crucial. So if the character is the end of file signal, then we need to tell the caller we already saw the carriage return from the previous iteration of our loop. So we will say return token.endLine here, and then the next time we call, we'll still be positioned at the end of the file, and so we'll correctly return end of file. However, if the character is a new line, then we have correctly parsed a new line, and we've consumed the new line character as well as the preceding carriage return character. So now we can increment our line number just like before, and then return token end line. However, if we now see any other character, then we have then what we just saw was a carriage return followed by a non-new line character, and that means we're in a Mac OS kind of world. And in that case, we do want to increment the line number, but we want to back up our pointer, in our input pointer, because then the character that we just saw, this unknown C, needs to be processed as if it were in the start position. So we will return token endline as well, but we have reset our input pointer so that that character C will be processed again the next time we call the getToken method. Okay, good. So that should take care of that. Let's run all of these tests again, and here's hoping that my machine is speeding up a little bit, but it doesn't appear to. It's a little faster now. Okay, well, fingers crossed. Let's hope that this is slightly faster than before. Still grinding away. Okay, there we go. So we're satisfied now that we're able to handle new lines. Let's finally dig in and take care of comments. So a comment is anything that begins with a semicolon, and it goes on to the end of the line. So if I see a comment like this, and I have maybe the word hello, and then a comment, and then a new line, and then world, I expect to see the two tokens hello and then world. And in between hello and world, I expect to see an end line. But the word comment will be ignored. That's the whole point of the comment. So our first token, get token, is going to get the word hello, and so we'll assert that hello is, oh, sorry, I confused the order here, that assert that we want to ask the assembler get the token string. So we'll check that we got a hello out of the assembler. The next token is going to be an end line token, and then we'll have a third token, which is the next token, which is supposed to be a word, and we're expecting that word to be equal to world. Okay, let's run our tests again. And this is going to fail because we don't have any implementation for comments. So let's go back then to our assembler and look at what we do right here at the start when we are just chewing white spaces and we encounter a semicolon. We need to shift into comment mode, or the comment state. So we'll say, if I see a semicolon, hello, then we'll completely ignore the character, of course, but then we'll switch our state to be state.comment. Oh, we got an error here. That's right, that's the expected error. Good. So let's generate that state and then continue. And then we have to go to the end of our parser, and here, when we are inside of a comment, as usual, we'll switch our case. And here again, we have to handle the case when we're reaching the end of the file. So if we're inside the comment and we reach the end of the file, we're going to simulate an end line. Because that would handle the case where you have written some instructions at the end of your assembly language source file and you didn't add a new line at the end. So we'll just return token end line in that case. No more input to see. And the next time we call this, we will get end of file tokens. So that's correct. If we run into a new line, then we will increment our line number because that's the end of our line, and then we will return token new line. So this is our end line. This is a new line inside of a comment. If we, however, run into the carriage return character, then we're in the same position as we were when we were just seeing a carriage return in the middle of the text stream. So what we want to do now is change our state to be state.carriageReturn, and then continue. So here we're sharing, we're reusing the state CR for handling carriage returns. If any other character is visible, however, we just discard it and continue reading through our text stream. So let's run our test that was failing and see if that now is more successful. Yep. Good. Now, let's go back to our assembler. Let's take a look at the contents of this assembler. We have all of these lines consisting of an opcode, or sorry, a mnemonic, and then 0 or more arguments following. And then we have these two, what I would call directives. And we can either decide that we want to recognize them just purely by their name. But I prefer a style where we actually syntactically highlight that these are not actual mnemonics, but they are instructions to the assembler itself. So this mnemonic, which corresponds to Risc-V instruction, we want to generate some Risc-V instruction when we run into this. But in this case, here we're telling the assembler, I want you to define a string. This is a directive. It doesn't correspond to a Risc-V instruction because this is data. And so I prefer a style when we indicate a directive by the presence of a period at the beginning of the directive like this. So this tells me clearly that this is a directive, and so I prefer to do a directive in this manner. And so to handle that, we'll go back to our assembler and we'll add another test case, which is just make sure that we can handle our directives. So we'll take this code and we'll add a directive, and it will just be a directive like test. And what I want to make sure is that if we run into that directive, we'll still get a word, but we want the whole body of the directive to be captured in the get token string. And now if I run this, this is going to fail because we are not recognizing dot. Dot is an unexpected character in our assembler right now. And so we will get an error. So what we'll need to do then is go to the case where we're saying if the character is an ASCII letter, or if it's an underscore, and I will add another case, or if the character is a dot. In that case, we will treat it as a directive. Furthermore, there is another case that I'd like to handle, and that is something I'm calling an operand directive. And this goes back to our assembly language program when we are generating these relocation references right here. Again, here I want to highlight that this is actually an operation that we want the assembler to do. And so I'm going to use the percent sign here, which is consistent with the assembler, the official Risc-V assembly language syntax. So this percent sign here also indicates that this is a directive, and so we will use that to distinguish PCRel directive from a symbol called PCRel. You might, for instance, have a program where you wanted to use this as a symbol. So we'll use the percent sign as a operand directive, and so let's put that in there. So let's then run our tests again. And one of them should pass now, the one with a leading period, but now we also want to handle the case where the word is initiated with a percent sign. I think those are all the tokens that we have in our program. Yeah. Now we can run this last one, and we should be good to go. Good, good, good. So now that we are able to tokenize, that is, convert the whole text file into tokens, we can now start parsing, which is to look at the streams of tokens and making decisions based on the token types that we see. So we're going to shift slightly in our testing approach now, because rather than working on recognizing tokens, we're now going to be working on recognizing sequences of tokens. And always bearing in mind that we are treating the assembly language program as a sequence of lines. So it makes sense then to have a method called parse a line, assemble line in the text assembler, which will assemble a line of of text. And we'll write one test. And here what we'll want to do is um, let's handle the case when we run into a label, first of all. So we'll say label. So what is a label? Well, a label is a situation where the assembly language program has, we're at the beginning of the line, and then we see a symbol, like a symbol, followed by a colon. Now that is a label. And so our expectation is that when our assembler runs into this, we're going to generate a new symbol. So let's create our assembler. And then instead of calling get token now, what we're going to do is uh, we're going to call assemble line. So we'll say tasm.assemble line. And this will have some side effects. It will create a symbol in a symbol table. And we'll want to verify that the symbol exists in the symbol table. So we'll go to TASM and we'll ask it, what are your symbols? And we'll say assert that TASM.symbols, and we'll look it up. Actually, we'll say contains key. We'll make this a dictionary. So contains key, and then we'll pass in the key symbol, like that. So now we need to define the symbols collection, and we also need to define the new method assemble line. So let's go ahead and do that. So assemble line now exists, but it's not implemented. And then we need to create a new property called symbols, which is a dictionary of symbols. I'll put it right here. And so this will take, it will create a mapping from a string, which is the name of the symbol, to one of these symbols that we already have in our other assembler. Let's set that up like this, and we'll call it symbols. Good. Good. So how do we recognize a a label? So assemble line, we are positioned at the beginning of a line, so we're going to go and ask for what the first token is. So let's go ahead and read that first token. And the first token, we will now ask the question, is this a word? So if token is equal to token.word, then we might be in a situation where we are seeing a label. But we need to first check the token that follows. But here's a problem. If we now call get token again and the next token is a colon, then we're happy that we've identified a label, and then we can proceed and process the label. But if that next token is not a colon, then we have mistakenly eaten or consumed one of the tokens. So what we really want here is a way to ask if the next token is a colon, but don't discard it, don't consume it. In essence, what we want to do is peek ahead. We want to look ahead one step and see, is the next token a colon? If it is, then good. Then let me consume it, and then continue. So we need to implement a peek mechanism. But the problem is that if we're doing a peek and we are doing multiple peaks in a row, we need to have a place to store the peaked tokens so that we can refer to it again next time we do a peak. So if I do two consecutive peaks, I don't want the assembler to advance to the next token. You should just reuse the previously peaked token. And then when I do a get token after that, I want to consume the peaked token and then advance after that. I hope this makes sense. So let's make a unit test to make it a little bit more clear. So the unit test is we're going to implement this peak functionality. And so what I want to be able to do is if I have two symbols like hello and world, I want to be able to go to the assembler and peek token. So we want to peek the next token, and we're going to assert that that will return the token type that we expect, namely um, token type word. So is equal to token word. So that should work. And let's put a number instead so we can distinguish these two. So if I do peek token again, it should still return word. And then if I do a get token, then I now get the token value again, but this time I will be consuming the the token hello. And so if I do a peek token after that, I expect it now to be a number. Okay, so now we need to implement peek token. So peek token will work like this. We're going to keep track of the most recently peaked token in a member variable. So we'll say token previous token. And we'll use the value token dot end of file to indicate that there is no token. So this is a signal value. And so if we peek token and the previous token is end of file, that means that we haven't peeked before. So we need to fetch a token from the stream. And so we'll say this dot previous token equals get token. Okay. And then we return this to our caller. And this should be safe. If we are not at the end of the file, then previous token gets that token of the next token in the stream, and then we remember it in our member variable, and then we return that to our caller. Next time they call this, previous token will not be equal to end of file, so we'll just return the previous token. So you can call peek token as many times as you want, and we will not advance more than once in our stream. But okay, so well, let's run the unit test first, and then we will discuss the other case, which is, well, actually, we have the unit test. The unit test will fail because get token needs to be altered as well. Get token needs to look and see, hey, has there been a peak before I was called? If there was, then we want to return that peaked token and then reset the previous token member variable to end of file to flag that there are no longer any pending or peaked tokens. So what I want to do here is introduce or rename the get token method that we've been using, and let's call it read token, and I'm going to make it a private member, and then change all the references to read token here, and then we want the new method token get token to work like this. So if the previous token was end of file, that means that no peek has been done. So then we just simply return the result of read token. The previous token will remain end of file, and so this just returns the token just like it did before. This is the case when no peek has been done previously. But if the previous token is not end of file, then that means that that peak token is the value that we want to return to the caller. So we'll hang on that as a result. But then we need to reset previous token to be end of file because now we're consuming the peaked token. So this does that, this accomplishes that, and then we return the result. Good. So let's run all of our unit tests now to see whether that is correct. And we have a failure with peak. Oh, right. We're not encountering any symbols here. So let's stop that. And what about label? Label is still not implemented fully yet, so we'll ignore that one failure for now. We're focusing on peak and making sure that peak is working correctly. So let's run peak. And it's passing. Great. Now we need to implement a symbol line. Now that we are armed with this peak token, now we can go to this position here and say we've just read a word. If the peak token at this point returns, if this returns token dot colon, then we're in good shape. We've now recognized that we've recognized the label, but we have to now discard the colon that we peaked. So we could, of course, just call get token here to just discard it. But it turns out that this combination of peaking for a particular value is so common that we'll want to do this in its own method. So let's add a method. This is a private helper method, I suppose. We're going to call it peak and discard. And so we'll have a token, which is the expected token, and we'll perform a peak. But if the peak is not equal to the expected token, then we want to return false. We'll say that, well, we didn't find the token that we expected, so we'll return false. But if it was the one that we expected, then we want to just discard the token that we just peaked. So the reason why we're discarding is the colon. The colon doesn't have a value. It's just a syntactic marker. So we will implement peak token like this. Sorry, peak and discard like this, and we finally have to return true to say we did see the expected token and we have discarded it. Good. So now we can say if peak and discard is a colon, we have now seen a symbol. But if we do this, by this point we have discarded the word. So let's hang on to the word that we saw here. We'll say get token string. So now we have the word. Now that word, after seeing a colon, now we know that that is a symbol. So what we're going to do then is just add it to our symbols. We'll add a method called add symbol, where we pass in the symbol. And well, what is the symbol? The symbol is our current position in the assembly segment, and we don't have an assembly segment. So let's create an assembly segment. And let's make that a property. Is it assembly segment? Yeah. No? I forget our class name. Let's go back and take a look. Assembler section. Okay, that makes sense. So let's rename that to section. And then this is also a section. And let's type it correctly. Good. So let's see, the assembler section, if we go back to its definition, it has a current position. So what we want to do is create a new symbol at this position. So we'll say the symbol is a new symbol where the value is the name, which is W, and then the address is the section dot position. Oh, we don't expose it, do we? Okay. Well, we can certainly add a property to expose that, so let's do that. We'll say public long position equals, and this is always going to be an unsigned integer, so I'm going to give ourselves a little room here. We'll say that the position is the result of casting the byte stream position to an unsigned integer. Okay, so now we don't need to do that cast over here, and instead we record the position in the stream, like so, and then we add the symbol in a new method that we'll be writing called add symbol. Now what should happen in add symbol? Well, we need to check to see whether there already exists a symbol with this name, and if there is, that's an error. If not, then we'll add it to our symbol table. So we'll use the dictionary that we have, our symbols, and we'll say try add, and we'll try to add this name and this symbol. And if that succeeds, we're good, we return. But if that fails, then we have to report an error. So we'll need to write an error to the output. Let's see. We'll, we'll use the same format as we were using over here. And here we'll say duplicate symbol. Okay. And then we need to put our valid state to false, because we've run into an error, and so therefore now the output of this assembly is going to be incorrect. Okay, so hopefully this now works. Let's go back to our unit tests and see if we can get this test to pass. And we're being slow again. Maybe I should stop Visual Studio Code and restart it, because this slowness is a bit painful. Well, let's give it a chance to run the test and see whether we get the expected result. It's very slow. And we fail. Now, why did we fail? Ah, we ran into this. How dumb of me. All right. Can we rerun this a little more swiftly? Looks like we can't. Let's quit Visual Studio Code. Yeah, it's taking a bit longer, no kidding. Okay, so uh, let's go to our command prompt and start Visual Studio Code again. It really looks like my machine is running through mud right now. Very, very slow. Okay, we fixed that one issue. Let's see if we can build everything and then go to our unit tests. The slowness is impressive. I may have to bring this session to a premature halt because this is not fair to the viewers. Um, but let's see. Can I... Oh, what happened to my tests? There we go. All right. Let's run all of our tests. Yeah, this is glacial. This is not feasible. So, dear viewers, I'm going to have to stop here and have troubleshoot why my machine is running so slowly. I apologize for that. I was hoping to make some more progress on their assembler. But let's just go through what we did achieve, which is to completely or finish all of the parsing of all, or lexing, I should say, recognition of all of our tokens. And we started working on recognizing symbols. And in our next session, we will continue work on the text assembler, trying to get to the point where we can assemble a few instructions directly from a text file. So until then, thank you for your patience. I apologize again for the slowness of my machine today, and I'll see you in another time.